Take it away.
Thanks, dude. All right, man. This is I like this. This is cool. It's good to be in Chicago. I was at this conference in Colorado about a month ago, this architecture conference. And so when I went there, it was with the Software Engineering Institute. And so the dude that went on before me was like this guy, this PhD guy from Europe, and he did this very fancy thesis presentation, and everybody there was wearing suits. And so then I came up like this, and they introduced me as the guy that would stand out. So I appreciate not standing out, hopefully as much here for you. So anyway, this talk is about using product thinking and product orientation with architecture. The background on me, so I worked at the Mercantile Exchange for about 10 years. Anybody here from CME? All right, good. If you haven't been there, don't go there. These are my own opinions. Feel free to not go there. So CME for about 10 years, and I was working at Red Hat for a few years. In the past 5 or 6 years, been doing this consulting stuff, kind of helping organizations go through this digital transformation. And the challenge I've seen is like groups are still struggling to adopt this product thinking in the basis of the way they build things. So when I was at the Merc, I did a bunch of architecture design. At Red Hat, same kind of stuff, and now I'm trying to help groups blend the two together. All right. One last caveat for you all. Don't throw anything. I do some of the agile coaching stuff. If I start using those words, feel free to throw stuff, and I will not be offended. I'll actually applaud you. All right. So here, this is kind of like my perspective on the world. I've never seen the best architecture. Who in here would say my architecture is the best architecture ever? Couldn't get any better. Yeah. It's never happened. So I've never seen the best architecture. I have seen a lot of groups, though, get wrapped up around architecture and never actually deliver anything. When I was working with this company up in Minneapolis, they were going through this digital transformation thing, and they brought in this agile architect guru guy. And this guy came up and said, there's no architecture in agile because everything just happens. And I was like, that's the most irresponsible thing you could possibly say. So like that dude said that, and then all of the architects got super kind of razzled saying, we don't have jobs because agile, blah, blah, blah. And the reality of it is like, it's always this kind of balance, right? There's things about your product and your architecture that are best guesses. And investing too much in them early on is kind of dangerous, but there's things that you have to get right, and if you don't get right, you lose. When I was at the Mercantile Exchange, biding my time, when I was at the Mercantile Exchange, we couldn't say, we'll just figure out network latency as we go. The traders won't care. It'll just happen over time. That would be irresponsible. There is fundamental things about the things that you build that you have to get right. And so what I want you to think about as we're talking today is how do you find that balance? And I'm going to give you some examples of stuff that I do. If nothing else, take this away. Behind every single architectural decision you make, there is an assumption about your product. Either it's an assumption about speed or about assumption around how people use it as it degrades or an assumption around how things are going to distribute and replicate. You have all these assumptions. And so if you use some of these ideas around products, you can start validating the product ideas with your architectural assumptions. These are the things we'll do. I'm going to spend a lot of time in this visual space. We're going to talk a lot about what architecture, and more about when is the architecture significant. You're always using product context to run your decisions, and then last but not least, some ideas on documenting your decisions. Because again, I know in Agile there's no documentation, probably a bad idea if you're building complex systems. All right, let's start off with what is architecture. This is architecture, right? Show of hands for the architects in the room. Yep, this is it, right? You just do some blue boxes, maybe some arrows. And so we draw these boxes, and then we give them to teams, and then teams mess them up because our boxes are perfect. Our boxes know what's going to happen. But in this simple example, you have a very generic kind of architecture. You have some kind of front end. There's some API. I know we're here at Spring Days, so maybe I should call that microservices. You have some kind of business logic, some calculations sitting back there. You have some data in the back end that has to move around. But I mean, you all know this isn't architecture, right? This is just boxes on a screen. There's all these subtle nuances. There's what happens with caches and what happens with data replications and what happens with access and storage and replication. There's all these other nuances that sit inside architecture. This is a picture from this book, Notes on the Synthesis of Form, from Christopher Alexander, a fabulous book, which I highly recommend. This book is about building buildings and building, kind of physical objects. And inside this book, Christopher Alexander talks about every decision you make when you build something has trade-offs. So if you're trying to build a building and you're trying to make it as cheap as possible to build, but also highly performant, those are not mutually exclusive items. So each of these items has trade-offs. Similar if you want a nice looking building or you want good jointing, all of these things have trade-offs, and so he starts to draw these models around when you're making decisions building physical objects that you have to understand the relationships between the components. So if we play this out a little bit further, this top one is more like the architectures we build today, the products we build today. There's lots of these decision points, and there's lots of interconnection pieces around how they would affect each other. If we make one decision in how we store data, it's not only going to affect the API and replication, it might also affect auditing and logging and other things. If we make a decision about security, it's going to affect these other decision points. If we make decisions around messaging, it's going to have impact around other parts of the product. And so the top one is, if you just take all those decision points in your product, this is what it might look like. The bottom is what we tend to do, this bias simplification, right? So like, if you think about, you have this product you're trying to build, and here's all these decision points, we get overly biased by the things we know. The things we know are the things we've read or the things we've built before. And so we tend to get a suboptimal decomposition of the problem space, that bottom picture. We tend to say, well, we know about some front-end stuff, and we know a little bit about the APIs. I really don't understand some of this data stuff, so I'm going to assume it's going to work like this. And you tend to sub-optimize things based upon the technology and the bias you have around frameworks or architecture. But what we're trying to get is more of an optimal decomposition, that picture in the middle where you can start logically grouping decision points together to make it easier to maneuver around the architecture. You're all building products. They live, they evolve, you're never going to get them right, and so you need to have ways of allowing those to grow with you over time. Everybody knows technical debt? You don't have any. I know you don't have any. The other groups, the people that aren't here today that have technical debt. What is technical debt for anybody? Gentleman in the front. Nice. Yeah, that's what you get for sitting in front. That's a business value is kind of the things you take care of, the things that kind of slow you down going forward. No? Okay. Non-functional requirements? Yeah. In most places, groups that I work with, technical debt is somebody else's code. Somebody else made some bad ideas way back. And so now I'm dealing with it, and I have to, somebody else copied and pasted, so now I have to deal with it. Ward Cunningham, the gentleman that created the term technical debt, I think actually said it in a much more humane way. He said, technical debt isn't that we did the worst thing possible, we took shortcuts. His take on it was, we did the best we could with the information we had at the time. As time evolves, our understanding of the problem space changes, and so technical debt is that gap between what we know now and what we know then. That's way more humane than saying, that last dude kind of copied and pasted from Stack Overflow, and now I'm dealing with it. I think keeping that in mind, though, is why you got to be thinking about how your products evolve and how it's going to affect your architecture. So applying these models to architecture, the things you work on are not simple. Even if you're working on WordPress, which is just ridiculous. I don't even understand WordPress anymore. But if you're working on WordPress, it's not a simple architecture. You have all of these interdependencies. Your components have trade-offs. And very easily, we get biased by the solutions we've built before or the languages we know. So let's talk about using this product stuff to ground the decisions you make. Look, here you go. Check this out. Everybody know what this is? The story map. Look, you're all Agile certified in story maps now. Woo! This is a story map. Simple concept. You have somebody that's trying to do something with your system, and there's things along the way. And they're not all stories, there's system interactions and blah, 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 all that fun stuff. Here's how it might play out in a bigger product space. So you got somebody, the users, the personas of your system, some of their macro level goals, and here's some of the things along the way that happen to have interactions with the customer or the user to solve certain problems. When I do story mapping, the skewed notes kind of there in the middle mean it's a non-human, it's a non-interaction event, right? So like if you're building an e-commerce platform, your users don't check inventory, but inventory has to be checked, right? So this is just a way of talking about for a person to solve a problem with our product, what does the flow and what do the options look like? This is an example of kind of blowing it out, and even this picture is about 4 or 5 years old. What I think is interesting about this is that the dude there, anybody want to guess who this guy is? This lovely gentleman? Oh, come on. He's the enterprise architect. That's why he's so happy. So in this example, they're walking through this product, and they have all these stories, and this dude, all of the orange sticky notes were his questions. What about fault tolerance? What about data integrity? What about this? What about that? And so what we started doing was overlaying some of his questions with when they became impactful across the experience. Some of his questions at the bottom you can see there weren't relevant. Well, they were relevant to him, just not relevant to what we're trying to do. You can see kind of that nestling inside there. But this picture is kind of how some of these ideas started evolving, laying out these product flows, having these architectural questions, and seeing when they play out. This is a more recent picture. Yes, this is a more recent picture. In this example, this is still a story map, and we just have some various things happening inside here. This is for a group I was working with that was building Network 4.0. So it was infrastructure, pure network. Logical question is what happened to Network 3.0? Similar to Angular, they skipped it. I don't know why. What was interesting about this, though, oh boy. Oh, okay, hopefully I don't give too much away. A switch vendor was coming in to help them with Network 4.0. And so like the infrastructure people were just going to sit there and listen to the presentation. And what happens is the vendor just tells you, here's the features you need. And then you buy things and you say, well, it doesn't work. And then they say you didn't do it the right way. What we did instead was we sat down with the network engineers and said, what are some things that people need to do with Network 4.0? What's the most important thing? What's more important later? When are these decision points for your network important? If they tried to build all of Network 4.0 right off the bat, it would be overly complex. But if they try to get like that, if you want to call it the 80-20 rule, if they wanted to solve a problem fast, what would happen? And it allowed them to make decisions earlier on, as opposed to trying to get the perfect architecture. So that's what this example is about. How this actually played out is way cooler because the next week, when the vendor came in, they were ready to do their dog and pony show. Here's the features, here's the things you want, blah, blah, blah. And then this team came up and said, well, we want to talk about this. And then the vendor goes, we're not ready to talk about that. We have to come back next week. I like that. I like when vendors, I used to work for Red Hat, so I can say these things. I like when vendors don't know what they're doing. All right. Going back to a story map here. So imagine this kind of made-up scenario where somebody's trying to book an online travel experience and not get dragged off a plane. So you'd have something like this, and you would see, like, here's some of these kind of travelers, and here's this story map talking about these macro-level decisions that somebody would have to do. They need to create a flight, they need to book it, they need to have some kind of profile, manage their accounts. And you can see all of these possible things that this type of traveler might need to do to book a flight and manage their flights, manage their preferences. So what's the architecture for this? Anybody? Box? It's a box. It's 3 boxes, actually, with some arrows, and just the team has to go build it. If somebody comes to you with this problem, right off the bat, you're probably starting to get biased with some things you've already thought about. You're probably starting to say, like, well, if it's gonna have to interact with some external APIs for the airlines, so we have to have some kind of mechanism for that. And it probably should be microservices because that's cool. And we need some kind of maybe non-relational data store for my profile. And you get all these ideas around how it should work and how it could work because of all the things it needs to do. And I want to do all this stuff, and that's fun. But if you were to take a simpler approach to it and said, what's interesting if the first problem we're trying to solve and validate is just could a family book a flight, what is architecturally significant for that interaction? And so then you start thinking about things like, well, as a family, you're not in a hurry to book a flight. You're usually doing more research. You're less concerned about kind of what's happening. You know, are all the prices updated right now? Is everything kind of real time? But you're more concerned about trends and being able to store data and come back to it. So the architecture could look a little different. You might have to put a little bit more into the kind of persistence and storage page and the revisiting space, but a little bit less time in the freshness of the data. So right now, like the most important decision for you to make might be around that storage of data and not around the APIs and integrations. But if you took a different approach and you said, instead of being a family traveling, this is going to be a business traveler. And so what do we know about the business traveler? He doesn't care about the price. He's doing the same kind of thing over and over again. He wants to book his flight right now because he's not really planning. It's very kind of cyclical and repetitive. It could be a different architectural thing. Right then, the freshness of the data matters because this dude might be saying, oh man, I got to leave tomorrow to go to this other city. I need a seat right now. Or you know what? My meeting ended early. I want to get out of town. The freshness of the data matters more to this person than the freshness of the data of the family. But if you try building both of those things at the same time, now you're taking that complex model and you're just adding more pieces to it. If you take another extreme example, anybody in here do backpacking or adventuring type stuff? Yeah? If anybody does, when you travel, how would your traveling be different?
You may not actually care where you're going, you just need to look for a cheaper flight.
Yeah, you don't really care where you're going, right? You don't care where you're going. I've been with people, when I ask them this question, they say, well, I don't care where I'm going, but I want the longest possible layovers possible because it's actually like free vacation at that point in time. Now, if you're thinking about that and you're optimizing against somebody else, now you're making different decision points based upon unknowns in your product. And so you have to have a deeper understanding of who's using these things, how they're using it, and how that affects your architecture. If I were to play this out in a different way, and this kind of helps some groups visualize their decision points, what you want to think about is when are these decision points significant and how does it impact the things you're building and people that you're solving problems for. In your decision points, you have things that if you're wrong about, the impact is isolated, where if you're wrong about them, it has deep impacts to your system. So that's kind of the left to right. Is this decision point isolated as best as it can be, or is it a linchpin for everything else we're building? And then you have the top to bottom around how well is this problem space known? Is it something you've built before? Is this the domain you're deep in? Or is it still a world of uncertainty? If you start from that aspect and you look at your decision points in these product maps, you can start overlaying some of these decision points across a simple matrix. So I mentioned at CME, this is of course is a made-up example, but at least contextually it'll work for you. There were things that we just couldn't get wrong. If the matching algorithms were wrong or the message latency was wrong, it would drastically impact the rest of the way the system was designed. So we couldn't say, let that emerge, we'll figure that out as we go. We had to figure out how do you lay these things in early enough and do enough due diligence to make sure that the cost of, your chance of being wrong or drastically wrong is less costly and less impactful. But there are other things like this data segregation. We couldn't know, data segregation for us was really based upon the markets. Based upon who wants the data, you would segregate data in different ways to be able to scale appropriately. we could look at analytics and we could do different things, but it was still something that would have to, it was relatively uncertain to us, because you don't really know how people are going to react to it until it's out there. But we could isolate it pretty well. And of course, there was things like logging frameworks and all of these situations, but this helps you get this visualization around the cost of being wrong and like what decisions should you move earlier, what's the risk of moving decisions earlier. Starting from this idea of a product, finding your decision points and laying them out visually like this. Does not solve all the world's problems, but it's a nice start. All right. How does this fit into the more modern world of things? So this simple story map, if you're trying to do cloud native development or microservices or all these other fun things that we have these days, I still use story maps to start talking about what are the boundaries and responsibilities for our services. If you have an existing platform, you could still do the same thing, and it becomes like a reverse engineering of the domain language. And now you can start talking about things like, okay, well, this whole booking of the flight could be its own independent service, and here's its ilities, and here's its boundaries, here's its responsibilities, and here's what it's not relevant for. If the purchasing side needs to find out something about the flight, here's how it interacts with it. So you might be able to see it here. There's like a, there's a magenta type box, a gray box here, a green box here, a yellow over here, and a different dish, yellow over here. This is still a super simple model. In this example here, you could say, well, that's very easy. None of your boundaries are kind of blurry. Yeah, I totally agree. I use LibreOffice, and I'm not very good with making squiggly lines. In reality, if you're doing this, and you're trying to figure out the domains of your services, they might go like this. You might have a little bit here and a little bit down here, and it might cross like this. And this might kind of have its skewed piece here, and something might go like this. But it starts the conversation around what are the boundaries of the services, how do we interact, and then what happens when things go wrong. You can also take this to say, is this really the right thing to do in a microservices approach? Who would, if we separated out the search aspect of this, who would possibly use it besides us? Or are we just kind of doing things to do things? It just starts a nice conversation. And of course, the chaos engineering side of the world. When I'm working with groups and we're doing this idea of story maps, and we start looking at the boundaries of the services, whether it be the boundaries of the services or even the functionality, this is a nice time to start having that conversation around what happens when this fails. Because people don't talk about that. None of your stuff would ever fail. None of mine ever has, but I joke. It fails all the time. But this starts a conversation of like, if we couldn't book a flight, is that significant enough where we should still keep up the profile stuff or the ability to look at other previous purchases? If the account maintenance is gone, is the product still significant enough to stay up? And if you don't have good reasons to make these things separate, then maybe you don't. Maybe you keep them together because independently they're non-interesting. So you have these conversations around what happens when, how do these things, where the responsibilities lie, what happens when they fail, all these type of situations. I was working with a group that was rebuilding their job submittal thing, because they get a lot of job resumes. And we did something as simple as this, and then they realized they really only had 4 kind of boundaries. And so one of the boundaries was really around all of the compliance stuff. And so they could build it once for the job submission stuff, but they could use it again internally. And they were able to have that nice discussion. Even if people couldn't submit jobs, this compliance thing is interesting because internally we can use it and all the good things for the organization. Seeing this in action, so this is a group that was doing some of these things. This just gives you a proof that I'm not making this up. If nothing else, just take it at that. They were talking about some personas over here. This was a lot around store support for a company. And so they have some some maps over here, and they're putting dots around different boundaries for different pieces of functionality inside here. Just a nice way of having a team communicate. This is actually an enterprise architect. This dude was really nice because he had a lot of domain knowledge, and he was able to answer the questions for the group. Where does the data lie? What happens when these things fail? Just a nice way of kind of bringing a group together. All right. Understanding the assumptions inside your architecture, because architectures are full of them. This is a fun one, right? Use these product ideas to validate how something will actually be used versus how you want it to be used. Just because you think you want to do microservices or cloud doesn't mean the use is actually leading it that way. On the flip side of this, good engineering practices, in my experience, will tend to lead to better architectures. So even if you're not doing microservices and all of those things, if you're doing responsible engineering, loose coupling of systems, test-driven development, if you're doing these things and you have nice testable systems, those will tend to lead to better architectures over the course of time. On the flip side of that, bad engineering practices will take the best architecture to its knees. I've done that as well. So just kind of think about those things. You know, are you building the things that people want, or are you doing kind of what you want, and how does that affect everybody? And then when you're wrong, and you're going to be wrong, what happens? When you're using those story maps, sometimes the first thing that you want to build is the thing that you know the least about, because the cost of change then is lower, and so then you can figure out validating this idea and this assumption, but always have an out when you're wrong. In your world, I would highly recommend that as you're building things, you're documenting your product assumptions as well as your technical assumptions, because they kind of go hand in hand. Now, these documentations around assumptions are not long-lived. Once you validate something was a good idea or a bad idea, you kind of move on from there. This isn't like, you know, I wrote this algorithm because of X, Y, and Z. It's like, here's the kind of context, here's why it works, and we proved it out. But for any decision point you're at, I challenge you all to think of 3 ways that you might be wrong. Because if you can't think of 3 ways you might be wrong, you're teetering on that, using that bias to get you a suboptimal decomposition of your models. So think about 3 ways you might be wrong. Usually, in my experience, the ways that I might be wrong tie back into my assumptions around the product. And so I would tie back and say things like, well, I'm assuming that people want to know right now exactly how many seats are available to make a decision because they want to buy right now. But if I find out they really don't care, and we're getting data that shows that they don't buy in real time, they kind of buy staggered over a period of time, then I could be wrong, and maybe I'd choose a different decision. And then for last thing there, for each of those possible errors, what would have to change for your system to be able to adapt to those errors? Is it simply just creating better interfaces? Is it better abstractions? Or is it one of those things where if you're wrong, your kind of lights go off kind of thing? Because that can happen. That's usually not a good space to get into. All right, wrapping up. Never been a perfect architecture. If you find one, let me know. It's probably like the Yeti. Get a picture and then sell it to National Geographic. Use this idea around product discussions to see what decisions you have to make, how it impacts your product, and when those decisions are relevant. Is it relevant now? Is it relevant later on? Is it an assumption that we're making based upon something that might happen a year from now? Know that your architecture decisions will probably not be right. But the benefit is then you can blame it on somebody else. And then last but not least, grow context around the decisions you're making. If everybody's talking like the same language around your product, here's how it's being used, here's the problems we're solving, here's why these decisions are interesting, and here's when they're relevant, then you have this kind of common language that people can rally around. And those languages tend to live longer than the understanding of the code, at least in my experience. Challenge your constraints, figure out what you can do about it. Are your constraints in your world necessary or accidental? Anybody here from security? No. I see lots of accidental complexities from security because people don't understand security. But what I find again is when you bring the security group forward and you talk about the thing you're building in the context of what you're building, then the security group has a better understanding and some of these security constraints tend to shift a little bit. But again, using this common language to bridge across these constraints. And then are your constraints assumed or real, right? This is again gets back into that bias. You've been at a company or you've been building something for so long that you think this is the way things have to be. Sometimes you just got to poke at them a little bit more and say, is this constraint real or is this just something that's been happening over the period of time? We're trying to solve this problem in this context for a customer. Historically, it's always been done this way. Does it have to still be that way or is there better approaches? So again, kind of getting yourself out of those biases. Sometimes new constraints help groups. Not all of the data, no new code. How would these new constraints help you rethink about your architecture? And then this kind of like hippie-ish thing here, right? Our job as software engineers is like this world of possibilities. All of these fun problems we could possibly solve and narrow it down and get common understanding and apply intentional constraints so that the things you build are actually enjoyable to people. And also open up your systems for future change. You create maneuverable systems. And I think you create maneuverable systems over time. Create systems that bring joy to your customers, bring joy to your future engineers. That would be a fun thing. If somebody called you 5 years from now and said, that code you wrote 5 years ago was so awesome, I just wanted to thank you for it. Anybody had that happen? No. Have you called anybody? No? All right. That's the recap of stuff we talked about, thinking about models and dependencies, always using these product discussions to help you avoid language bias, use these visuals to kind of figure out your boundaries and how things play together, talk about your services, what happens when things fail, understand the interdependencies, and understand the things inside your architecture that you have to get right versus the things you possibly couldn't get right now. And how would you learn to get there? The two books I mentioned, probably didn't mention the first one, the Three Errors is from Jerry Weinberg. If you haven't read Jerry Weinberg stuff, I recommend it. And the bottom one, Notes on the Synthesis of Form from Christopher Alexander, also a solid book, talks, again, it's about building physical objects. It ties very closely to the things we do. That's what I got. What do you got?
There's time for questions.
Yeah, what's up? Yeah. So the question is, how do you blend the cost of the architecture with the need of the product? I mean, to me, that still feels like a bunch of these opportunity costs. And I think what happens, maybe some enterprise architects are getting better at it. In a lot of situations I go in, the teams that are building things don't have a good correlation to like the cost or the opportunity of the things that they're building. And so I always find this conversation around what's the impact of the thing we're building on either revenue, as well as what's the cost of being delayed on these things. And so for some of these things that you're building, if the cost of the architecture is so high, then that's a real constraint and you have to figure out a way to work around it. You have to do something else. If it's something that has to evolve over time or you can't get there yet, like I use that example of the flights thing. Because if you think about a flights thing, that's something that could be very expensive over the course of time. If you're trying to do messaging across multiple systems and you're trying to spin something up at a very large scale to do all the airline interactions, that's going to be pretty expensive. But if you hone it in and say, before we spend all that money, is there a simpler approach through the architecture that we could validate these ideas that we should keep building? That's usually a nicer way to justify it before you actually write the check. So trying to find shortcuts so you can actually justify this spend later on. Please.
So how do you find the reusable components in this whole journey, right? Often it's a painful, right? Like we think that it's not reusable and we go and build, but after a certain time we think that's reusable and we go and refactor it. Takes some time.
Yeah, I think so. The question is, how do you find the reusable components in these types of things? So there's two facets to it. So one to me is the reusability. So are you talking about reusability within a team or reusability within an organization? So those are two different things.
Like you're building something
Across the product itself? Yeah, so if I have, kind of scaling it up there, if I have one team with one product and it's going to be used in multiple spots, then I always come back to these visualizations and I talk about what was the context of this entity or service or thing we're building, and could this serve something else elsewhere? If it becomes beyond that, like how do we find reusable components outside the team? Like, as your organization grows up, the challenge I've always found there is never around the product so much as it is the organization. Like there's been plenty of times where I was joking with the gentleman earlier before my talk. I was with an organization that just moved to Git, but none of the developers can see anybody else's code internally. And it's like, so when you try, but they always talk about reusability. It sounds ridiculous. I trust me, I had this conversation. It is ridiculous. But the challenge there wasn't how do you find the component to reuse. It was everything organizationally was put in the way to block it. And so then as soon as we started removing those things, then people could actually do Git searches or artifact researches, or they have internal discovery services or Apogee type of things. Then they could find the services and reuse those components, again, assuming they're service-based. But there's also the other side of it where it's like, maybe you don't want to reuse it. It might sound blasphemous, but there are situations where reuse is probably expensive because I want it 85% of the way, and you want it this way, and then you want it this way. I had one group that had this problem, and then they created 200 APIs on top of the one thing so it could be reusable. But it was horrible. Yeah. They would have been better off having separate pieces that would actually serve their needs. So again, coming back full circle to it, if I'm one team, I use this thing and still talk about as the product grows, how could we reuse these things, and is the context changing? If the context changing, then I got to rethink about is this a new service or is this something different? If it's outside teams, then it's usually different approaches. Yeah, what's up, dude?
Yeah, I'll speak up. See, there was a comment you made about two services joined because independently they're uninteresting.
Yeah.
What is that tipping point for you? And then I have another question after that.
But two services are joined in an interesting way?
You made a comment earlier that you might have two services and you'll join them together because independently they're uninteresting, or like you may need them functionally together.
Oh, yeah. So like,
What's the tipping point? When do you finally say, like, you know what, let's just do it?
tipping point to bring them together, tipping point to separate them.
Well, actually both, but really
Yeah.
the point of bringing them together. Because one thing I've noticed, and this will lead in the second question, is we try intentionally to keep things very isolated and independent, but we find that like they keep wanting to come together.
Yeah.
We're trying to adhere to a discipline as well as be realistic.
Yeah. So I actually take the opposite approach. And this might sound horrible. I try to keep things more closely together, usually based around kind of like the domain of the things, as well as these kind of questions of if this thing was not available, what's the impact to the other situations? And if this one thing being down means this other thing is unusable, then I don't know why I'd want to separate them. And so I start with that kind of like decision point of keeping them together versus if they were separate and one fails, is it still usable?
So with that perfect segue into this next question, sometimes teams just, we have the greatest intentions, but we follow certain patterns, and because we can't, we use a dependency or,
Yeah.
right? And how do you influence how do you structure the environment to disincentivize that behavior, right? Like using your services that way, kind of controlling.
So like by using a dependency, do you mean like an external library? Do you mean like an external service? Just kind of all of the
Building
above?
internal services. So you may call your services improperly across, like, you bring those two independent services together.
Yeah.
And now you're calling it in ways that you want to use through the service layer or certain.
Yeah, so just kind of bad practices.
Yeah, how can you, without forcing the environment to be only one way, like always following a certain pattern or discipline?
Yeah.
You create these like mini monoliths and then you kind of break your own rules because you can.
Yeah, because you can't, yeah. That's, I don't think there's an easy answer to that question, to be honest with you. Like, this kind of goes back into that good engineering practices tend to have good things emerge, and bad engineering practices or rushes tend to kind of bring the best idea to their knees. And so that's, the only experience I've had where things work in a better manner is where people understand the core concepts of what they're trying to prove. Proper good isolation, proper decoupling. Like I had this group that was trying to do microservices. And so, again, no knock on the enterprise architects here. This group was building this product, greenfield. They had it working. Like, it was ready to ship. The enterprise architects came in and said, okay, now it has to be microservices and it has to be deployed on OpenStack and these other situations. So they took this application that was working and they made it 30 microservices. And now they couldn't actually deliver it because they couldn't get all the versioning properly right and everything was peeled apart. And so that example, I sat down with the architects and we had to talk about what was the fundamentals they were going for. The fundamentals they were going for were loose coupling of systems, easy to migrate, easy to maneuver. They could get that without having to be microservices. And so it was just kind of coming back to those core principles of like, what do we value inside the system? What might change and how do we get there versus kind of chasing.
Microservices. They had a distributed monolith.
Well, that's actually how it wound up, yeah. Yeah, so I mean, I'll just say, dude, like, I don't think there's an easy answer. I think you just have to have groups that kind of like, I don't want to say get it, but like are open to wanting to get it.
Yeah.
Do you know that group I'm talking
What's
about?
that?
So, you know
I've
that
seen
group?
this movie.
You've been there before?
I've seen this movie.
Yeah. What else? Or am I out of time?
We're getting pretty close. You have one more. Someone's there.
Anybody else? In the back, the blue shirt. Sorry, dude, you're too slow.
You were very good talk. I really enjoyed it. When you're talking about engineering teams, you mentioned experience. People want to either do new things or they've done it before, so they make really funny squiggles.
Yeah.
Generally, though, experience is something good. I want to hire a carpenter. I want someone who's done something before. So how do you balance somebody's preconceived notions of experience? How do you make sure that the experience is used appropriately instead of repeating a bad pattern?
Yeah.
I don't know if if that's how you coach people, or
Yeah, that's fine. So the question is, how do you, experience is valuable, and so how do you actually make sure you get the best out of experience without creating kind of this kind of biased solution type thing? And to me, it still comes back to those product things. Like, sitting there with a group and saying, I know you have this experience with relational databases or, non-relational, or, how does this problem help us solve this situation? Not without talking about the technology, but talking about the outcomes and the things that are going to happen. It's just a continual balance. I mean, I had one group, dude, where like I sat down and the group was going to do, what's the Apache messaging thing? Not Spark. There you go, Kafka. And this group, the architect came in and said, we're going to use Kafka. And so the problem space was probably right. It was it was stores, 2,000 stores nationally, so a distributed messaging system kind of made sense. But then the dude kind of went crazy. And he was talking about how it was going to shard and how he was going to replicate and how he was going to distribute it because he had all this experience around it. But then we kind of took a step back and said, what is the messaging queue solving? Okay, it's keeping stores in sync with inventory. How frequently is it doing it? Maybe once every couple minutes. Okay, so the load is X. So all of your concerns around sharding and everything else kind of don't really make sense right now because the load doesn't make sense in the context of the thing we're building. The solution still makes sense, good idea in the messaging approach, but all of the other underlying complexities that you want to build underneath it, probably not right now. So it's again kind of balancing those two things out. We good?
We're good?
All right. Thank you.
Thank you.